In this video, we will talk about diodes. Diodes are basic yet evolutionary devices employing semiconductors. Diodes are very basic electronic switch. Diodes are two-terminal devices. The name of terminals are anode and cathode. Cathode is characterized by the band and its electronic symbol is this, in which triangle represents positive and strip represents negative. Consider diode as a one-way gate or a one-way valve. When water is filled from this side, then after a certain amount gate is opened and water flows to second part. As more water flows, gate gets more open and more water flows to other side. This happens to a point when so much water is filled that gate is completely opened and puts no restriction on flow of water. In this situation, the pressure of water is voltage and flow of water is current. Now if we fill water on other side, no matter how much water is filled, gate will not open. The secret to this behavior lies in construction of diode. A diode is made up of two semiconductor blocks. One is p-type semiconductor which have excess of positively charged holes and n-type semiconductor which have excess of negatively charged electrons. When they are diffused, recombination of electron-hole pair takes place which form a depletion layer which has no charged ions. Now, when diode is connected in forward bias, which means P is connected to positive and N is connected to negative terminal, the holes and electrons move towards depletion layer and gets deposited on either side of the depletion layer. This creates a potential difference across depletion layer and weakens it, and after a certain voltage it breaks down and current starts flowing through diode. Now, when polarity is reversed, that is, P is connected to negative and N is connected to positive terminal, the holes and electrons move away from depletion layer and thereby increasing the width of depletion layer, which makes it more stronger and no current will pass through diode. This behavior of diode can be verified by a small experiment in which a power supply, a diode and a LED is connected in series. If diode is connected in forward bias, the current flows in circuit and LED should glow. And if diode is connected in reverse bias, the current does not flow in the circuit and LED should not glow. Let's move on to experiment. Here I have a setup in which this is positive and this is negative. The current should flow from here to LED then to negative terminal. Let's test this circuit with a wire first. And we can see that circuit is working properly. Now we will remove this wire and take a diode. In this diode, this band represents cathode and other side is anode. First, we will connect diode in forward bias. And we see that current flows and LED starts glowing. As you can see, anode is connected to positive terminal and cathode is connected to negative terminal, which makes it forward bias and current is flowing. Now, we reverse the polarity of diode and connect anode to negative terminal and cathode to positive terminal. Now, diode is in reverse bias, which does not allow current to flow and LED does not glow. This behavior of diode grants us with very important application called rectifier. Rectifier is a device which converts alternating current to direct current. This means instead of getting positive and negative cycle of AC, we get only positive cycles. There are two types of rectifier, half wave rectifier and full wave rectifier. Waveform for half-wave rectifier and full-wave rectifier are shown. Let's see how this works. When a diode is connected to an AC supply, with the positive cycle, anode becomes positive and cathode becomes negative, which makes diode forward bias, and positive cycle passes to output. For negative cycle, anode becomes negative and cathode becomes positive, which makes diode reverse bias and negative cycle does not pass to output. Here we have a setup with a breadboard on which AC supply is connected. The second screen shows oscilloscope's display. Let's connect the probes to input. As we can see, oscilloscope shows AC signal. So input is AC having positive and negative cycle. Let's make a half-wave rectifier on breadboard. Take a diode in which input is given to anode and output is taken from cathode. Then we will connect a resistor between cathode and ground. Let's take output on oscilloscope and see waveform. As we can see, second channel in green shows output, which gives only positive cycle. There is output only for positive cycles and there is no output for negative cycles. So we get only half wave as output, hence the half wave rectifier. Now, if we make arrangement like this, then for positive cycle, these terminals become positive and these becomes negative, which makes these two diodes forward bias and current flows as this, which makes this terminal of resistance as positive and this as negative. So, for positive input cycle, we get positive output cycle. For negative cycle, the positive and negative terminals of diode gets interchanged, which makes these two diodes forward biased and direction of current is like this, which makes same terminals of resistance positive and negative. So, we get positive cycle as output even for negative input cycle. Here, we have a setup like this, in which these two are AC input and we get output from across the resistance. Let's connect USB probes across output. And as we can see on second screen, it is only continuous positive cycles. Since we get output for both positive and negative cycles, hence the name full wave rectifier. Here we see the input AC supply. and this is full wave rectified output. That's it for now. Keep learning, keep watching, and please like, share, comment, and subscribe.